Mathematics is a universal language. It is the language of patterns, of logic, of the cosmos itself. Every civilization has contributed to its rich tapestry. Ancient India wove threads of extraordinary brilliance. From the Indus River to enlightened courts, India cultivated a profound mathematical tradition. This is the story of that tradition, a journey through brilliant minds and elegant discoveries. The history of Indian mathematics is a testament to human curiosity and the pursuit of knowledge. Join us as we explore its origins, celebrate its triumphs, and trace its enduring impact. The roots of Indian mathematics run deep, reaching back to the cradle of civilization in the Indus Valley. As early as 3000 BCE, the people of this advanced civilization displayed a sophisticated understanding of mathematics. Archaeological evidence unearthed at sites like Harappa and Mohenjo-daro reveals a people who used a standardized system of weights and measures. Their meticulous urban planning with its grid-like streets and precise brickwork suggests a strong grasp of geometry and spatial reasoning. While we have yet to decipher the Indus script fully, the remnants of their civilization speak volumes about their mathematical prowess. These early Indians were not just counting, they were measuring, designing, and building, demonstrating a practical understanding of mathematical principles. This foundational knowledge, passed down through generations, would lay the groundwork for the remarkable flowering of Indian mathematics in the centuries to come. The middle ground between the 5th and 12th centuries CE marks a period historians often call the classical era of Indian mathematics. This period was a time of extraordinary intellectual ferment. It was during this time that a constellation of brilliant mathematicians emerged, each building upon the work of their predecessors and making groundbreaking contributions of their own. These were not isolated scholars working in obscurity. They were often supported by royal patronage and worked within a vibrant intellectual culture that valued scholarship and debate. From Aryabhata, the astronomical genius who calculated the approximate value of pi, to Brahmagupta, who dared to contemplate the concept of zero as a number, to Bhaskara II, who explored complex equations and the properties of infinity, this era witnessed an explosion of mathematical innovation. These mathematicians were not content with simply solving problems. They sought to understand the underlying principles, to develop new methods, and to push the boundaries of mathematical knowledge. Their work, often recorded in meticulously crafted treatises, would form the bedrock of Indian mathematical tradition and exert a profound influence on the development of mathematics worldwide. In the tapestry of Indian mathematics, Aryabhata shines as a particularly bright star. Born in 476 CE, Aryabhata emerged as a mathematical prodigy. At the age of 23, he composed the Aryabhatiya, a groundbreaking astronomical treatise that would become a cornerstone of Indian astronomy and mathematics. This remarkable work, written in elegant Sanskrit verse, covered a wide range of topics, including arithmetic, algebra, trigonometry, and the motions of celestial bodies. Aryabhata's genius lay not just in his mastery of existing mathematical knowledge, but also in his ability to innovate and expand its horizons. He developed methods for solving linear and quadratic equations, laid the foundations for trigonometry with his table of sines, and even provided a remarkably accurate approximation for the value of pi. His work on astronomy was equally impressive, proposing a heliocentric model of the solar system centuries before Copernicus. Aryabhata's legacy extends far beyond his own time. His Aryabhatiya became a standard text for astronomers and mathematicians across India, transmitted and translated through the centuries, its insights shaping the course of scientific thought for generations to come. Section 5. Brahmagupta, Master of Algebra and Astronomy. Brahmagupta, born in 598 CE, stands as another towering figure in the history of Indian mathematics. His masterpiece, The Opening of the Universe, is a comprehensive work on astronomy and mathematics that cemented his place as one of the greatest mathematicians of his era. Brahmagupta's contributions to mathematics are both profound and far-reaching. He made significant advances in algebra, developing rules for handling negative numbers and zero, concepts that were still struggling to find acceptance in other parts of the world. Brahmagupta's work on geometry was equally impressive. He developed formulas for calculating the area of cyclic quadrilaterals, and made significant contributions to the understanding of Pythagorean triples. His work on indeterminate equations, a topic that had fascinated Indian mathematicians for centuries, demonstrated his extraordinary ability to grapple with complex mathematical problems. Brahmagupta's influence extended far beyond his own time and place. His work traveled westwards, carried by Arab scholars who recognized its brilliance. Through this transmission, Brahmagupta's ideas on algebra and the decimal system would eventually reach Europe, influencing the development of mathematics during the Renaissance and beyond. Section 6, Bhaskara II, the crest of the wave. Bhaskara II, born in 1114 CE, represents the culmination of the classical period of Indian mathematics. His work, characterized by its clarity, originality, and depth, pushed the boundaries of mathematical knowledge in several directions. His most famous work, the Crown of Treatises, is a comprehensive treatise on astronomy and mathematics that showcases his extraordinary mathematical prowess. Bhaskara II excelled in algebra, geometry, and trigonometry, building upon the work of his predecessors and adding his own original insights. He made significant contributions to the understanding of quadratic equations, providing a method for solving them that is still taught in schools today. His work on Pell's equation, a type of Diophantine equation, demonstrated his ability to tackle complex problems with elegance and ingenuity. Bhaskara II was also a gifted astronomer. He refined existing astronomical models and made accurate predictions about eclipses and planetary motions. His work stands as a testament to the heights achieved by Indian mathematicians during the classical period. Section 7, Zero, a mathematical revolution. The concept of zero might seem obvious today, but its development represents a profound leap in mathematical thought. While other civilizations used place-value systems, it was India that gave the world the concept of zero as a number in its own right, a concept that would revolutionize mathematics. The earliest known inscription of zero, found in the Gwalior fort and dating back to the 9th century CE, attests to the early Indian understanding of this crucial concept. The Indian concept of zero, known as shunya, went beyond a mere placeholder. It was considered a number with its own properties, subject to the rules of arithmetic. This understanding allowed Indian mathematicians to develop sophisticated systems of arithmetic and algebra, enabling them to perform complex calculations with ease. The adoption of zero as a number was a game changer. It paved the way for the development of the decimal system, a system that would eventually become the standard for representing numbers worldwide. The impact of this innovation on the development of mathematics, science, and technology cannot be overstated. Section 8, The Power of 10, India's gift to the world. The decimal system, based on the powers of 10, is one of India's greatest gifts. With 10 digits and place value notation, it represents any number simply and efficiently. Developed by the 5th century CE, it spread westward through traders and scholars. Adopted by the Islamic world, it reached Europe, revolutionizing calculations and paving the way for scientific advancements. Section 9, Spreading the Word, the transmission of mathematical knowledge. Indian mathematics is a story of transmission, enriching the world. Indian mathematicians were part of a vibrant intellectual network, connected by trade routes and scholarship. The Silk Road connected India to China and the Islamic world. Buddhist monks carried mathematical knowledge. Texts were translated into Chinese and Tibetan. The Islamic world also received this knowledge. Arab scholars translated works into Arabic. Baghdad's House of Wisdom preserved and disseminated this knowledge. Section 10, The Kerala School, Precursors to Calculus. While the classical period of Indian mathematics witnessed remarkable achievements, the story doesn't end there. In the southern state of Kerala, a new school of mathematics emerged in the 14th century, pushing the boundaries of mathematical knowledge in new and exciting directions. The Kerala school, as it came to be known, focused on a specific branch of mathematics that involved infinite series and calculus-related concepts. These mathematicians developed sophisticated methods for calculating the value of pi to an unprecedented degree of accuracy. They also made significant advances in the study of trigonometric functions, developing power series expansions for sine, cosine, and tangent, concepts that would later form the basis of calculus in Europe. The Kerala school's remarkable work on infinite series, predating European mathematicians like Newton and Leibniz by centuries, raises intriguing questions about the transmission of knowledge and the possibility of earlier influences. While the exact nature of the connection between the Kerala school and European mathematics remains a subject of debate, their work stands as a testament to the enduring power of human curiosity and the universality of mathematical thought. Section 11. Conclusion. An enduring legacy. Indian mathematics is a story of intellectual achievement and enduring ideas. From the Indus Valley to the Kerala school, they made groundbreaking contributions. They developed zero, revolutionizing number representation. They gave us the decimal system, now a global standard. Advances in algebra, geometry, and trigonometry shaped mathematical thought. Indian mathematics impacts technology, architecture, and our understanding of the universe. Celebrating Indian mathematicians honors human ingenuity and universal knowledge.